For years, we've heard the same old story, right? Hydrogen is the fuel of the future. It's always felt like this thing that's just over the horizon. Well, guess what? That future is showing up a lot faster than anyone expected. So let's get right into it. So, the big question is, are we finally there? Is this really the moment where all that hype, all those promises, finally turn into actual physical pipelines and real-world production? Because, the groundwork, it's being laid as we speak. That massive leap from a shiny press release to hardcore industrial execution, yeah, it's happening right now. And there's a specific year you need to circle on your calendar, 2026. That is the tipping point. Seriously, this is the year when all those giga-scale projects that have been stuck on the drawing board finally move into full-blown industrial execution. This is when the theory stops and the steel actually goes into the ground. Okay, but before we dive headfirst into this global race, let's make sure we're all on the same page. What is green hydrogen anyway, and why does it matter so much? Because trust me, understanding this is the key to seeing just how enormous the stakes really are. It's actually beautifully simple. You make green hydrogen by splitting water. The process is called electrolysis. But here's the absolute game changer. The electricity you use for that, it has to come from 100% renewable sources, like wind or solar. The only things that come out the other end are pure hydrogen and pure oxygen. That's it. Zero carbon emissions. It is that clean. So let's just walk through that real quick. You start with plain old water, H2O. Then you zap it with an electric current from a clean source, like a solar panel. And that jolt of energy literally splits the water into its two parts, hydrogen and oxygen. It's a fundamentally clean process from the very beginning to the very end. Now, this brings up a really important question you're probably asking. Hey, why don't we just use batteries for everything? And look, batteries are awesome. They're great for our cars, for storing energy on the grid, but you just can't power a giant steel mill or a massive cargo ship with the battery. It's just not practical. Those hard-to-abate sectors, the really tough nuts to crack, they need a powerful, transportable molecule they can burn. They can't just run on electrons from a wire. And that right there is where green hydrogen becomes the only real clean solution for the world's dirtiest job. So, okay, how do you actually make this happen at a massive scale? Well, at the very heart of this whole revolution is one critical piece of tech, the electrolyzer. That's the engine. It's the machine that actually does the water splitting. And right now, there is this absolutely fascinating global race going on to see who can build the best one. And there are basically four main contenders in this race. Think of it like this. You've got alkaline, or AWE. That's your trusty old workhorse. Super reliable, super cheap. Then there's PEM, which is like the high-performance sports car. It's compact, it's efficient, but boy, does it need some expensive, rare parts. Then you've got the challengers, AM and SOEC. They're trying to give you that sports car performance, but with common, off-the-shelf parts. The entire industry is placing huge bets on which one of these is going to come out on. And this really gets to the central drama, the title fight happening in the engine room right now. You've got PEM, the reigning champ, versus AEM, the up-and-coming challenger. PEM's a beast. It's a high-performance leader, but its Achilles heel. It's totally dependent on iridium, which is one of the rarest, most expensive metals on Earth. AEM, on the other hand, is promising that same kind of power and efficiency, but without needing any of those crazy expensive rare metals. I mean, whoever wins this fight could literally define the cost and scale of green hydrogen for decades to come. So who is actually building the gigafactories for all this stuff? Well, let's look at Europe. Their strategy is all about high-tech innovation. We're talking engineering giants like Siemens and Bosch leading the charge. They're creating these things called hydrogen valleys, which are basically these self-contained regional hubs. The hydrogen is produced and used right there, on the spot, by local factories. It creates this perfect local clean supply chain. Pretty smart. China's strategy is totally different. It's all about one word, scale. They are using their absolutely massive domestic market to just hammer down the manufacturing cost of that older, more mature alkaline technology. And this number right here, this is why their plan is so dangerous for everyone else. At just $200 per kilowatt, their cost is way, way below their Western competitors. They're not just playing, they're positioning themselves to become the world's factory for the entire hydrogen economy. And then there's India. Their strategy is completely different again. It's all about global exports. You've got these industrial titans like Reliance and Adani leading the way. Their plan is simple but brilliant. Harness the country's endless sunshine and powerful wind to make just unimaginable amounts of green hydrogen. Then they'll convert it into green ammonia because it's way easier and safer to ship and send it all over the world. It's an incredible idea. They're basically planning on shipping sunshine in a bottle around the planet. Okay, so building these giant factories is one thing, but achieving commercial success? That's a whole different ballgame. The entire industry now has to cross what they call the valley of death, and it's as scary as it sounds. It's that incredibly dangerous gap between proving a technology works in a lab and actually turning it into a profitable, scalable business in the real world. And this right here is hurdle number one, and it is a big one: cost. The simple truth is, right now, green hydrogen is still a lot more expensive than what we use today, which is mostly gray hydrogen. That's the stuff made from natural gas in a process that, by the way, pumps out a ton of carbon dioxide. Closing this cost gap, it's probably the industry's single biggest challenge. But here's the crucial thing to understand. The industry knows this. It gets it. And that's why we're seeing a big shift away from these splashy, "we're going to the moon" announcements. Instead, everyone's focusing on the tough, complex, on-the-ground work of actually building these facilities. It's not just about hype anymore. It's all about execution. And if you want proof, look no further. The initial production target for 2030 was this staggering number: 49 million tons. Well, that's now been revised down to a much more realistic 37 million. But listen, this isn't a sign of failure. It's actually the opposite. It's a sign that the industry is growing up. The market basically did a pipeline cleanup, getting rid of all the speculative, wishful thinking projects. And what's left? The serious, fully financed projects that are actually going to get built. And believe me, the challenges go way beyond just the price tag. I mean, think about it. To get the billions in financing you need, you have to find buyers willing to lock into contracts for years. You need access to massive, massive amounts of pure water, often in sunny, dry places where water is already super scarce. You've got to secure a stable supply chain for those rare metals if you're building the high-tech stuff. And maybe the biggest one, you need a power grid that can handle a factory that sucks down as much energy as a whole city. Solving these real-world problems is every bit as critical as just building the plant itself. So, okay. Despite all those massive hurdles, the race is well and truly on. And the moves being made right now, they're setting the chessboard for a completely new global energy landscape. This isn't just about the next few years. This is about forging a brand new energy map for the next 100 years. Just look at this timeline. It shows you the incredible sprint that's required. Right now, we're at about 1 million tons of production. The target for 2030, 560 gigawatts of global capacity. That is a mind-boggling jump. And 2026, when all those gigafactories finally switch on, well, that's the moment the starting pistol for that sprint really, truly fires. And as this whole race just accelerates, you can already see a new world of specialists starting to emerge. You've got China leveraging its insane manufacturing might to become the one who builds all the machines. You've got sun and wind-rich regions, think the Middle East, think India, positioning themselves to be the world's new gas stations, the new energy exporters. And then you have places like Europe and the US focusing on what they do best, inventing the next generation of high-tech gear. So, the pieces are moving fast and the race is on. But let's be absolutely clear about one thing. This is about so much more than just clean energy. This is about raw economic power and global geopolitical influence. The question isn't if the green hydrogen economy is going to happen anymore. That ship has sailed. The real question, the one that will define the 21st century, is who is going to own it.